Hey, and thank you for sticking with us on Virtual Azure Community Day, track 1. Next up is Shailendra, and Shailendra is a cloud solution architect at Microsoft. And he has a lot of experience in building solutions and helping other people, like most cloud service architects do at Microsoft. Hi, Shailendra.
Hi there.
Hey, how are
Thank
you
you for
doing?
having me here.
Yeah, thank you for joining us on this event. So, can you tell me a little bit about what your talk will be about? Because I think people might have heard of Dapr, but are not very clear what it might be.
Mhm. Sure. So see, we live in a world where everybody is talking about cloud native application. Few days back, we all spoke about cloud and migrating application to the cloud, and now it's time for us to actually start building application for the cloud or cloud native application. One very important piece of cloud native application equation is microservices. And don't make any mistake, microservices is very hard to implement.
Yeah.
So this is where Dapr comes in, and Dapr helps you to solve those common challenges. So you are free to focus more on business logic rather than solving these common challenges. And that's why it's uh, it's um, it's so useful to use something like Dapr, which simplifies things for you and get up to you on speed and get going very fast.
Okay, interesting. Well, I'm already excited to learn more about Dapr. So, thank you very much for joining us, and take it away.
Sure, thanks. So, hello and welcome everyone. Thank you for joining me in this session about building cloud native application with the distributed application runtime, also known as Dapr. My name is Shailendra, and I work as a cloud solution architect in Microsoft. So, the agenda for today's session looks like this. First, I would like to talk about what is the meaning of cloud native application. I'll try to build a common understanding. What is the meaning of cloud native? Why to think about cloud native, why it is important for us. Then I will talk about what are some common challenges in building these cloud native applications. In the next session, I'll talk about the distributed application runtime, Dapr. I'll talk about what is Dapr, why should we use Dapr. I'll talk about the Dapr Sidecar architecture, and then I'll talk about various building blocks Dapr provides. I'll also show you how you can build your application by using Dapr building blocks with help of some demos. And finally, we'll take some common question about Dapr. So let's first talk about cloud native. What is cloud native? Cloud native is a name of an approach for building applications and services specifically for cloud environments. Cloud native is an adjective which specifies application, architecture, platforms, and processes which together help us to quickly respond to changing business needs and growing customer needs. In simple words, cloud native is application code and dependencies packaged as containers, deployed as microservices, and exposed as APIs. And this all can be managed with DevOps pretty much. Service mesh, container exemplify this approach. Now we have talked about a common definition of cloud native. Now let's talk about why cloud native is important. First, cloud native help you to do speed at innovation because we are making use of cloud native technologies like DevOps and microservices. Developers can quickly take in an idea and implement an application for it and deploy it to production. With transparent feedback loop, they can see how their application is performing. And this way, they can change the course of their action. Next, by use of cloud native technologies, we get reliability. Application built with cloud native approach can help us to get most of the cloud, which means availability, resiliency, scalability, and low latency with minimal operational task. Using managed services designed for cloud scale and performance, we now switch our goals from cost saving to being the engine of business growth. Last not the least is security. The more we use cloud native approach, the better we can control the security. We can automate security checks, run intelligent threat detection, and provide real-time protection, and put fine-grained guardrails at every layer from bare metal to container images, reducing the risk of breach. Now we have defined cloud native, its advantage. Now let's talk about some of the scenarios where we would like to use this cloud native to build our application. The first scenario is when you want to modernize your business critical applications. Next, when you want to build this SaaS service application. You can also see a rise of solutions of real-time telemetry. You can see that we live in a world where we are collecting a lot of information from different devices, name it like smart buildings, smart cars, or everything smart. They are generating a lot of data. You get this data, move it to the cloud, and do analytics on that. To build these kind of solutions, you can also use cloud native technologies. Last, you can build geo-distributed applications with cloud native approach. Now let's talk about microservices. Microservices architecture is a very important piece of cloud native equation. So let's talk about what are microservices. Microservices is a software architectural style where you create a system by combining a number of independent services which are loosely coupled. These services are talking to each other by using standard protocols like HTTP or gRPC via well-defined interfaces. These services are very much decoupled, meaning that if you do some changes in one service, they does not affect other services as long as you do not change the interfaces. These services are independently versioned, deployed, and scaled. This is one of the biggest benefit of microservices architecture. As you can see in this picture, I'm comparing two architecture for same application. So on the middle side, when I say monolith, it's an application which is built with layered approach. On the right hand side, the same application is built with microservices where the system is built with various services. Now, if I have to scale, see how they scale. So in case of a monolithic application, I scale as a single unit. I have to scale all part of application. But in case of microservices, I can scale depending what portion of the application needs scaling. So for example, I will show you in the next slide about an e-commerce application. Let's suppose suddenly I have a lot of order to process. And then instead of scaling the entire system, I can just scale that part of the system which is related to the order processing. One very important benefit of microservices architecture is that you can use different technology, languages or frameworks for different services wherever it makes sense. For example, making UI, I can make use of Node.js or React. And then for building any event-driven application, I can use frameworks like Azure Functions or anything else. This is one of the example microservices architecture. You can see that when building an e-commerce application consists of several services, you can use a stateful actor to represent your cart service. And then at the same time, you can call stateless functions like shipping service and the payment service. And again, as I mentioned in the last slide, you can use different technology stacks or framework for implementing these different these services. Now we spoke about cloud native, we talked about microservices. Now, all these new things or new way of building applications and new approach brings a lot of challenges for us developers. I would like to highlight few of them. We are asked to develop resilient, scalable, microservice-based application which interact with other services, not only services inside, but also outside. In many cases, we have to build systems which react to events happening outside or trigger something which is happening out of something which is living outside of our system, also known as event-driven architectures. These microservices application are increasingly polyglot, meaning that different portion of these microservices are built using different kind of technologies. When we transit from this layered architecture or monolith to microservices architecture, we do not want to discard all the functionality we have developed. We want to make use of those existing code wherever possible. All the application which are running successfully today on microservices, many of them actually are transited from layered architecture to the microservices architecture. Last but not the least is that we want to leverage very powerful programming models like functions, workflows, and virtual actors. Now, we have also spoke about like microservices are very important. Now, there is something about these microservices architecture which is holding us back. Why it is so difficult to implement? Well, it's kind of very hard to incrementally migrate from existing layered architecture to the microservices architecture. You need to know about few decomposition pattern, or you need to take your code and migrate to the microservices architecture. It's pretty hard. It's pretty hard. Next, these programming models, what we are targeting, they have limited or narrow support for few of the models. So we have to rely on these programming models for certain kind of functionality. For example, if my underlying platform is not providing me a virtual actor model, I'm pretty much limited what I can do with my service. Next, these runtime, they target only specific infrastructure and environment, which limits us the code portability or application portability across cloud and edge. So I hope in this section I'm able to explain you what is cloud native, why should we develop cloud native application, and what are the advantages and disadvantages and some of the challenges associated with microservices application. Now I'll go to the next part of our presentation where I'll talk about the distributed application runtime, Dapr. Dapr is a portable event-driven runtime for building distributed application which can run across any cloud or any edge. Dapr solves the common challenges in building microservices application. Before I go and show you more about the architecture of Dapr, first question, why I as a developer and architect should use Dapr? Why? What is the reason for using Dapr in building my new cloud native microservices application? Well, Dapr is based on best practices building blocks. It has taken all the best practices from microservice application development and implemented them as building blocks. Dapr building blocks can be used in any language or any framework. I'll show you in my demo this feature of Dapr. Dapr is open source. All Dapr is developed is by community engagement. It is community driven project and it is very much vendor neutral. It works across all the clouds and across the edge devices. Wherever possible, Dapr has adopted standard like OpenTelemetry or cloud events. Dapr provides consistent, portable, and open APIs, which are very much important for portability. It is platform agnostic and works for different clouds and edge. One of the most important features of Dapr, because it is community driven and open source, is that it has an extensible and pluggable component architecture, meaning that you can pretty much go and do changes in Dapr and expect it to work because this is everything source code is available on GitHub. What is Dapr? Dapr helps you to build microservices application in any language or in any framework. As you can see that Dapr works across these clouds. It works on Azure, it works on AWS, it works on Google, it works for Kubernetes, it works for Service Fabric, because these Dapr building blocks, as you can see, service to service invocation, state management, all of these building blocks are exposed as standard HTTP and gRPC API. So you can make use of these building blocks in any of code and frameworks. Like for example, you have Go, Node, Python, .NET, Java, C++, and more. When I will show you some demo, I'll show you that how you can make use of this building blocks in your application by just calling standard APIs. Now, how do you do that? How do you make use of these building blocks in your code? So Dapr provides functionality to your code as a set of standard local endpoint. So as you can see that all the building blocks of Dapr are exposed as local endpoints. So as if you can see in this URL, I'm exposing the states management block by this URL, this format. I'm doing a localhost call, and I'm accessing a state store called inventory. In the same way, if I have to do service to service invocation, I'm actually doing this call, and I'm doing invoke, which is the standard way to access the service to service invocation block. And then I'm calling my service and a method on it, the new order method. Now I have shown you like what is Dapr, what devices or what clouds it works for. I'm also sure now I want to show you that how does a building block for Dapr looks like. So as you can see that each building block of Dapr is a standard HTTP or gRPC API backed up by one or multiple components. It is exposed as standard API, HTTP or gRPC, and you can pretty much use any component. So if, for example, if I'm doing local development, I can use a Redis state store. If I am in the cloud, I can use Redis, or I can use Azure Cosmos DB. If I'm in AWS, I can use DynamoDB. So this pluggable architecture of a building block helps you to just do some changes in the configuration YAML file and change the component. Now, going forward, I want to show the sidecar architecture, sidecar and component architecture of Dapr. As you can see in this application, an application is built with two services, service A and service B. Both of these services have their respective sidecars, Dapr sidecars. And when these services have to access any of the Dapr building block, like state store, pub sub, or bindings, they have to do a local endpoint call. So they are not calling these components directly. All they are doing is that they are making a local host endpoint call and accessing this functionality. Even in a case when this service has to invoke a function on this service, this service will make a local endpoint call to this sidecar, and this sidecar, with use of mutual TLS, will speak to this sidecar. And then finally, the function will get invoked over here. Dapr has two hosting mode. First is the self-hosting mode, where the application code accesses the building block using an HTTP and gRPC protocol. Here, the sidecar runs as a sidecar process. Similarly, in the Kubernetes mode, the sidecar runs as a sidecar container in the same pod where your application service is running. Now, when you take this application, you develop and deploy it to a Kubernetes cluster, it looks like this. So this is my application code, which is running together with this Dapr sidecar in the same pod, and they are accessing the standard building blocks of Dapr by using these pods. As you can see that this pod, which is providing most of the functionality of Dapr, is accessing different building blocks of Dapr on behalf of this service. I hope I'm making sense. It's not too heavy. This picture also shows that when you go to cloud, you have different options. You can have pretty much you can use different components for each building block. You have AWS DynamoDB, Cosmos DB, Redis, Cassandra, and many more for state store. In similar way, when you will be implementing pub/sub scenarios, which is one of the very important pattern in building microservices application, you can use Redis, you can use Nets, you can use RabbitMQ, and Service Fabric. One of the beauty of this architecture is that the number of components is increasing day by day. So if you go to the GitHub repository of Dapr, you can see that with each release, we are increasing the number of components for a given building block. Now let's talk about Dapr's building block one by one. The first building block I want to talk about is state management. State management is an important requirement for a microservice. So for example, I have a service, my app, and it is running with its Dapr sidecar. Now I want to do something with state management. How I will do that? I have specified in my components architecture what kind of component Redis or AWS DynamoDB or Cosmos DB I want to use as my state store. Once everything is done, then I can start using that functionality via by my Dapr sidecar. How I will do it? Let's suppose I want to store something in the state store. As you can see that I have made a standard HTTP call over here. I'm accessing the state store. I'm specifying the name of the store, and I'm passing a payload. Dapr takes it, look it into the component file and see what component I have chosen. Let's suppose I have chosen Redis, and it will store the value like this. Next time, I want to retrieve this value. I will again make an HTTP GET request like this, and I will access it by using the key. So you can see that how simple state management is provided by Dapr to me. The next building block is service invocation. Let's suppose I have an application front end which wants to make a call to method call to a backend service like a card. So as you can see in this application, I'm posting I'm invoking a method called checkout on this card service. This front end will make a request to its Dapr sidecar, which will speak to the Dapr sidecar of the card service and do the operation. Pretty simple. Now I have shown you enough talk. Let me switch gears and show you some demo. So the demo I want to do is a very simple demo where I would like to show you state management and service to service invocation. So this is the standard Dapr samples repository I have cloned on my PC. I want to show you an application. Let me show you the picture for this application. So this is a demo I want to show you. So I have a node application, which is an order app, which has this Dapr runtime. And whenever I'm posting a new order to this code, it is storing in the state store. In my demo, I have chosen Redis as my state store. So let me show you how it does. So I want to do this. Now I'm in my application. This is my node application. As you can see that it's an application. It's a simple HTTP server implemented in Node. It's listening on port 3000, and then it is mapping some requests. So it is for this is for get, this is for post, and this is for delete. Now let me run this application. with its Dapr sidecar. So this is the command to run a Dapr application with its sidecar. So as you can see that I'm running Dapr with the application ID node. The application port is 3000, which I have specified in the code. And then my Dapr sidecar will run on port 3500 and the application command to run. So right now I'm running the app.js. If I go over here and let me show you how many sidecars are running as of now. This Dapr is Dapr CLI. Now this command will list all the sidecars running in my environment. So as you can see that I have run one of the sidecar which is running is for the Node app, and it's listing on this port. Now let me show you how. So now I switched to this sidecar. Now my application is up and running. It is giving you a lot of information like what kind of components it has found. So because I have a component directory on my folder, pub/sub, state store, and YAML. In this pub/sub and state store, I have specified Redis as my state store. Now let me post some sample data to it. So now I'm posting some sample data. I have a sample.http file, and look at the way I'm going to post the data. So I'm making a standard HTTP post request with order ID 42, and I'm sending a request now. By the way, I'm using Visual Studio Code, and I have a tool called REST client, which is making me to call requests just directly from my ID without leaving anything. So I'm just sending a request. I have made a request, and the data is successfully persisted into the state store, as you can see from the state store. Next time, I want to make a request to get what is there in the order ID. And I get order ID 42. So as you can see that how simple this is to call the state store building block of Dapr. Now I will extend this demo, and then I will start a Python application. The Python application is pretty simple. What all it is doing is that it is doing service invocation on this, as you can see from this URL, on the Node app. I have hard-coded this name of the app over here, but which is not a good idea for production environment. But just for the sake of simplicity, I'm using that. So as you can see that over here is that this Python application is making a local host call to its Dapr sidecar and invoking a method on Node app called new order. Let me run this application. And what all this is doing in a loop, it is actually posting orders. So now the Python app is starting, and soon it will be up and running. And I will be receiving order. Yeah. So as you can see that this Python app is up and running, and it has started posting orders on its sidecar. And from that sidecar, the orders are going to the Node app. And I want to show you that what is happening in my state store. So as I told you that I have chosen in this example my Redis cache as this state store. See here. So I have order ID 14, then I have 16, 17. So every time this Python app is posting a new order, it is getting stored in my state store. So with this demo, I'm showing you how easy it is to do state management and service to service invocation. And as you can see that I'm using a Node app and a Python app, but both these applications are actually just doing standard HTTP calls to their sidecar. I'll stop this application. Oh, actually, no, I should have not done that because I just wanted to show you something more. Okay, I have started it again. It's again running, again receiving order because my Python app is still running. I want to show you this, that how many sidecars are running right now in my development environment. I'm doing a Dapr list and I expect to get 2 applications. And yes, so I have a Python app and a Node app running. This is Dapr CLI, and by using this Dapr CLI, you can pretty much do a lot of operations. This Dapr CLI actually is pretty handy and very much used in while you are developing your application. So I'll stop this one and switch back to my demos. So now let's talk about other building blocks. Now that the next building block or next feature which a microservice application needs is this pub sub scenario. As you can see that I have a card application over here and it is publishing a topic order. Now I have 2 subscribers, shipping service and the email service. Because when these services start shipping an email, they are telling their Dapr sidecars that which topics we want to subscribe for. And in this case, both this shipping and email service has said to their respective Dapr sidecar that, hey, we want to subscribe for topic order. And once these Dapr sidecars, which are connected to each other, and they are using this Redis as pub sub store, they found a topic of order, they will deliver it to shipping an email. And Dapr guarantees the reliable delivery of these messages. So I remember that few days back, I did a mistake while doing a demo and I malformed the JSON. And because there was no way for me to actually fix this, Dapr was still trying to post that order to these services. All I have to do is that I have to go back and delete that from the store. Next building blocks is bindings. There are 2 kinds of bindings, input bindings and output bindings. Input bindings help you to trigger piece of your application when an event from an external resource has occurred. So for example, if something happening in these external system, you can execute a code inside your application. In the similar way, you have output bounding. In output binding, you actually invoke external systems based on some events happening in your system. So for example, in this case, I'm invoking some different systems. So I can choose to invoke something on a Cosmos DB or a Kafka or Twilio or Event Hubs. So this way, Dapr with this resource binding building block helped me to build event-driven architectures. The next building block is quite important for implementing microservices application. As I told you before, when you build this microservices application, various services, in case of an e-commerce application, for order processing from the moment it is posted on the UI or from a user interface or on a mobile application, from that moment till it gets dispatched, there are so many services that are talking to each other, something known as distributed operations. So when you build these kind of systems, distributed tracing and diagnostic is very important. I have also specified before that wherever it is possible, Dapr has adopted standards. So in this case, Dapr has adopted open telemetry standards. So it can export trace and logs to these different kind of systems for Datadog, Jaeger, Signal, and much more. This will help me to find out what's going around in my system. The next building block is secret. As you can see over here, that this is the way I can access, especially this part, secrets. I can use any vault, say Azure Key Vault or HashiCorp Vault, by using Dapr. And Dapr can use any of these components. It can use Azure Key Vault, Google Key Management. This helped me to do the secret management. And with the latest release of 0.9, I can also do a local secret management, which is not recommended for production scenario, but it helps me to understand how things will happen when it go to production. Dapr also helps you to do vault management with Key Vault, Azure Key Vault. So as you can see that my application code is running in Azure Kubernetes Service. And then whenever I have to do any secret management and I'm using Azure Key Vault as my secret store, I can do this localhost call and get the data out of my vault. Same way, instead of using Azure Key Vault, you can use local Kubernetes secret store as specified over here. And again, see how the URL has changed. So now this time it has Kubernetes in it instead of a vault. Dapr has so many SDKs. It has SDK for ASP.NET Core, for functions, for logic apps. It very well integrates with these high-level developer frameworks. So in the next demo, I'll show you how Dapr integrates with ASP.NET Core. So let's switch to the demo. All the samples which I'm showing over here are coming from the GitHub repository. So now in this demo, I want to show you that how simple it is for me to use Dapr for using state management and PubSub with ASP.NET Core routing. So I'm showing you a routing sample over here. I have a ASP.NET Core application, and in my startup.cs, I'm telling to enable this application for Dapr by saying like services.add Dapr client, and then I'm mapping different endpoints to different requests and registering them with the topics. So let me first run the demo and then explain you this code sample. So I'm going to again start my application. As you can see here, and then I'll be running the application together with its sidecar. So as you can see that here, I'm running the ASP.NET application, and the application is listening on port 5000. So my application has started, and now it's listening on port 500. And because I have mapped these points with it, like deposit withdraw, I can do a lot of operation. So this application is not so secure banking application, which I'm using to deposit money into my account and withdraw at the same time, and also to know what is the balance. So let me show you that again, the sample HTTP file. This time I will be making standard HTTP calls. So see here, I'm doing a request. First, because I have ran this sample before, let me check if there is already some balance in my account or not. So I'm sending the request. Yeah. So right now I have this balance in my account. Now let me deposit some more money to it. So I'm doing a standard HTTP post, and I'm passing this payload that, hey, this is my account ID and this is the amount to submit. And I'm posting that. As you can see that the balance has increased. Again, I want to see how much balance is there, is 83. Now I want to withdraw some money. I want to withdraw everything. Oops. Oh, what I have done? Well, I have, by mistake, instead of withdrawing, I have deposited money. Now let me withdraw some money. As you can see, this is the request I'm doing. And I have withdrawn some money. Now I'm showing you like how I can play with my not so secure banking application implemented in an ASP.NET Core application. I want to show the same application not only can accept HTTP post and HTTP GET requests, but it can also take the same request as topics. So as you can see here, I'm withdrawing some money by use of a topic. So I'm publishing a withdraw topic and I'm withdrawing this much money. Let's see what happens. So the event has published successfully and now my balance is 61. I want to this time withdraw all my money. Now the balance is 0. So as you can see that I'm publishing a topic with withdraw. Now I want to publish a topic with deposit and want to submit some money. Let's see. Okay, now the balance is 150. So as you can see that how easy it is for me to actually integrate Dapr with my ASP.NET Core application. And this time I have used .NET Core SDK, and all the plumbing is actually happening in this startup file. So look for these things. In my startup file, this is what I'm doing. So by using this call, what I'm telling my ASP.NET Core runtime is that I'm registering the Dapr integration with controllers at Dapr. Give me a minute. Just give me a minute. Just give me a minute so I can. And then here I'm saying that to register a middleware for cloud events. So every time whenever there is a topic, it can extract that data from the request. And the next, I'm mapping these HTTP GET with these function, and also at the same time I'm registering this with these topics. So as you can see that how easy it is to actually use Dapr with ASP.NET Core routing. I have same sample scenario for controllers also, where you can see that I have a sample controller and I have decorated it with different annotations over here. So I hope I'm able to show you that how easy it is to use Dapr with your application with standard HTTP or gRPC calls, but at the same time, you can also make use of this high-level SDK in building your application. Now let me switch back to my demo. And yeah, that's pretty much I have. Thanks for joining. I hope I'm good on time.
Yeah, you certainly are. Thank you very much for your session. It's a very new topic for a lot of people. So thank you for explaining Dapr to us and showing some examples. Now I like that they added functions recently.
Sorry, say that again.
That they also added like functions, Azure functions.
Yes, yes. So with the release of 0.9.0, they have released a new capability called as Dapr extension for Azure, or actually Azure Function extension for Dapr. And this is a pretty much a very good release because this helps you to build this event-driven architecture and also utilize the serverless capability of Azure Functions. If you go on the open source blogs, cloudblogs.microsoft.com, you can find an announcement recently that now that there is an extension for Azure Functions which help you to utilize all the benefit of Dapr.
Oh, cool. Well, that's something to check out very soon then. I'm sure that we have Mark already in the house. He will check it out probably. So there's a question I have for you, and it's around service meshes. Now, you know, Dapr has a lot of functionality built in, but you know, should you use a service mesh or should you use Dapr, or is Dapr a service mesh? Can you elaborate on that a little bit?
Actually, that's a very good question. So, you know, yes, I agree that there is a lot of overlap between functionality of Dapr and service meshes. So there are service meshes around there which offer you some functionalities. But if you see Dapr is not only providing you the functionality and features of service meshes, but other functionalities also. As you can see that Dapr is providing you, integration with functions. It also provides you how to build workflows. So if I am an architect of an application and if I have to choose only few tools to build my application, because remember, maintaining a lot of tools and frameworks and runtime is also a nightmare, I would definitely go more towards Dapr. But as I told before, that when you want to use Dapr, you can choose some of the building blocks and leave some of them. You can use one, you can use two, you can use all of them. And Dapr plays very nicely with other softwares like service meshes or reverse proxies out there.
Yeah, okay, thank you. That explains it very well. And well, obviously it's also a bit of like the choice, like Dapr is more on the enhancing, like implementing functionality to your application and develop it quite more rapidly, I think, yeah. So
see, if you see Dapr is quite new. It's not more old than just a year, even less than that. If you see that how it has grown from release 0.1 to 0.9, and we are soon going in coming months, there will be a final release. If you see that how this has grown and how much developer attraction we are getting from community and all over the world, it's pretty amazing. Yeah. And this is open source, give you all facility to take it, some part of it or all part of it, and use it with your existing systems.
Yeah, it's rapidly being developed as well. A lot of new functionality being added like all the time. It's quite difficult to even keep up, but it shows, I think, the popularity as well. Now, talking a little bit about a possible downside. So it looks like if you want to access your data, you pretty much need a key value pair there.
Yes, that's a very important observation. So as of today, the state management is provided as key value pair. But you never know, in future you might have more scenarios. So by this presentation, not only I'm telling you about what is Dapr, but I'm also inviting you to take part in the development of Dapr. And there is a big community out there who are already working very hard to add more functionality. So maybe in future we have more functionality, and they might have released something in 0.9 which I'm not aware about.
Okay, cool. Well, we'll look out for all the updates coming in the future. I have another question, and it's around implementing retry policies.
Yes. So there is a way. I'm not so sure about how exactly you do that, but Dapr does at least few retries before it dumps the message.
Okay, cool. Well, that's more research then, maybe some homework. Well, thank you very much for giving this amazing session. We will try and share some links in the chat as well. And of course, if you have any questions, just put them in the chat. Not only for this session, but all sessions. I'm sure that they will get answered.
Yeah. Sure.
Okay.
Thanks.
Thank you very much. We're going to a short break now, so stick around for the next session, and see you later.
Thanks. Thanks, everyone.
大家好
Kamusta?
Servus.
Hi.
Hi.
Bonjour.
Jasas.
Hi.
Hoi. Ik ben
I'm
Floor.
Ryan Stropek from Austria.
日本からこんにちは。私は桑高之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schot uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, kamusta? I'm Ruby Jane Cabagna from the
Hola.
Philippines.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Shailendra from France.
Hello, I'm Ruth from France.
שלום. אני ערן ספילר מישראל.
from the Netherlands.
Bonjour, I'm Olivier from
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.
大家好
Kamusta?
Servus.
Hi.
Hi.
Bonjour.
Jasas.
Hi.
Hoi. Ik ben
I'm
Floor.
Ryan Stropek from Austria.
日本からこんにちは。私は桑高之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schot uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, kamusta? I'm Ruby Jane Cabagna from the
Hola.
Philippines.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Shailendra from France.
Hello, I'm Ruth from France.
שלום. אני ערן ספילר מישראל.
from the Netherlands.
Bonjour, I'm Olivier from
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.